Energy will be our next topic of thermodynamics. Internal energy, this as it sounds like, it is the same thing which is present internally in everything that is present, that you can feel, that is tangible. Every tangible thing has an internal energy. Intangible things does not have any internal energy. All tangible things has internal energies. Now, what we are looking at is that, suppose I am having a pen. Okay, suppose I am holding this pen. This pen has an energy. If I throw this pen at the speed of light, then according to the Einstein equation, it will make E equals to mc square. Like that, internal energy for every substance, we can write for every substance, uh, that is, for every tangible substances, it is also important for every tangible substances, which is associated with a definite amount of energy. Every tangible substance is associated with a definite amount of energy. Okay, a definite amount of energy. Understood? Now, why it is called that definite amount of energy? Because uh, it cannot be infinite. Okay, it cannot be infinite, and it cannot be zero as well, because for anything to be stable, to be present, it needs some form of energy. Okay, anything, suppose we are talking, we need some energy to talk. Plants need energy to grow, to photosynthesize. All reactions that are occurring in the universe needs some energy to actually occur. So every tangible substance is associated with a definite amount of energy. These energies can never be infinite, and these energies can never be zero. Okay, for any substances, for any substance. Okay, now, what does intangible means? Or thought, what we think, wish. I wish I have a car. That means my wish is something which is not associated with any definite amount of energy. Okay, that is known as intangible substances, intangible things. But tangible things is something which is there, which is present. Okay, so every tangible substance is associated with a definite amount of energy. Now, or you can also omit the tangible thing. You can write every substance is associated with a definite amount of energy. Okay. Now, next part is that this energy depends upon its chemical nature. This energy depends upon its chemical nature. Okay, depends upon its chemical nature. So the internal energy is dependent on the chemical nature. Can we imagine, or can we think of any substance which is not made up of chemicals, or not made up of any atoms, or which is not made up of, yes, atoms, protons, electrons, and neutrons, or any subatomic particles? Can we imagine anything which is independent, or not dependent, or not made up of these atoms? There is no such thing. There does not anything that exists which does not have these things in it. So the energy depends upon its chemical nature. Okay, the energy depends on the chemical nature, upon the chemical nature of the substances. Okay, upon the chemical nature of the substances. Understood? Okay, this energy, which depends on the chemical nature of the substances, is responsible for its state of existence. Okay, this energy is responsible. This energy is responsible for its states of existence. Responsible for its state of existence. Okay, this is responsible for its state of existence. Understood? So this is, in short, what is internal energy is. The change in internal energy which occurs during the chemical reaction. And for a chemical reaction, suppose you are going from A to B. Okay. for any sort of chemical reaction. Chemical reaction means permanent change. Physical changes which occur. That means if I am doing a reversible reaction, then that is a different issue. But when you are doing a reversible reaction as well, the phase are getting changed. So internal energies are always changing. Understood? Now, the internal energy change which occurs during the internal energy change. Now, one more thing. Internal energy is represented with the letter E or U. We have discussed in our previous class. This is represented with E or U. For our assumption, we will take this U1. Okay, when I'm writing here, I will use this U thing. Okay, the internal energy U is, or the change in U, means internal energy, that is delta U. The change in U, that is delta U, which occurs during chemical reactions, which occurs during chemical reactions is the difference between the internal energies, is the difference between the internal energies, the U of initial reactants, reactants and final products. Okay, initial reactants and final products. So the difference, the change in internal energy during a chemical reaction is the difference between the internal energy of the initial reactants or the reactants and the internal energy of the products. Okay, so we will write that delta U equals to U of the products minus U of the reactants. Okay, U of the products minus U of the reactants. So this is as a whole what we call about an internal energy. The questions will come from this statement, from this segment only. And one of the most important thing is that when we will be studying about the law of thermodynamics, that is the first law of thermodynamics, we will be learning a few in a while. Then we will understand that how a process like isothermal process is there, how in an isothermal process the internal energy of the initial reactants or the reactants and the internal energy of the products becomes same. Okay, during an isothermal process we will understand about the fact. We have discussed about the isothermal process in our previous class, and here we will going to understand the application of that isothermal process, where we will be finding that the change in internal energy for an isothermal process is zero, which can only be possible if the internal energy of the products is equal to the internal energy of the reactants. Okay, now let us understand about the next thing, which is known as enthalpy. Internal energy, and the next one will be enthalpy. Enthalpy is also known as the heat content of a system. Enthalpy, Enthalpy. Enthalpy, it is represented with capital H, and it is also known as the heat content of a system. It is also known as heat content of a system. Okay, I am not going directly to the part about the Cp and Cv, where heat content at a constant pressure or heat content at a constant volume. I'm not going to that part here, but now we will be focusing on the enthalpy. Now let us understand about the concept of enthalpy. The concept of enthalpy is very simple. Suppose there is a woodcutter, okay, who cuts wood for for their household. Okay, so one fine evening when he brings wood from the forest, his wife or he himself uses those woods to burn, to light up the light and to light up and do the cooking. Okay, whenever the woods are excess, whenever the wood is excess, then what does he do? He takes those woods and give and go to its friends or it's somewhere else or in the market and sells those woods. Okay, so the woodcutter bring woods, and woods are used for making fire. Okay, woods are used for making fire. Okay, woods are used for making fire. That is, it is giving energy. Okay, what type of energy? Heat energy. Energy in the form of heat. Okay, it is used for generating energy in the form of heat, which is used for cooking. Now, if I have excess of wood, excess of wood, suppose the woodcutter has excess of wood, so he distributes it, he distributes it, okay, he distribute it, and when he has less wood, he brings more. Okay, he brings more. Okay, where he distributes in the surrounding, in the market, and he brings from the surrounding or the market. So what is this wood? Actually, it is equivalent to the energy in the form of heat. So if I have excess of heat and if I distribute it, that means I am I'm giving out the heat. Okay, I am giving out heat. I am giving out heat, and here I am taking heat in. Okay, so when I have excess, I'm giving out. When I'm taking, when I have less, I take in heat. So in a reaction, when heat is being given out, when a reaction occurs from a reactant to a product and heat is formed in the product side, then we will say that the reaction is exothermic reaction. And when heat will be absorbed in the reaction for the process of formation of the products from the reactant, then we will call it as endothermic reaction. Okay, so there are two types of reaction. One is exothermic reaction and the other is endothermic reaction. Okay, so there are two types of reaction. One is exothermic reaction and the other is endothermic reaction. So excess of food. So we have exothermic reaction. Okay, exothermic reaction where heat is evolved, during the process. Okay, where heat is evolved during the process. But there is also another type which is known as endothermic reaction, where heat is absorbed, okay, during the process, which when heat is absorbed during the process. A simple chemical reaction of endothermic nature is that if you like to dissolve potassium chloride in water, you will find that after a few moments the beaker in which you are making the solution of KCl, it is actually becoming cold, and you will see that some droplets are coming. Means the bowl, means the thing that you are having, it is becoming cold, and you can see that droplets, means the water vapor which will be present outside, will condense on the walls of the beaker. So that is an experiment which you can actually, if you want to, you can do it in your lab, in a school lab or somewhere else. But this is thing. And exothermic reactions are all those type of reactions from, suppose you are diluting sulfuric acid. You are pouring sulfuric acid to water, because you have to pour acid to water so that it does not sprinkle out. Acid is at higher density and it will shrink, it will just go and sink in water. And during this reaction, when the H2SO4 is dissociating to H plus and HSO4 minus, or twice of H plus and SO4 2 minus, this dissociation actually causes a lot of evolution of heat. And this type of reactions are also regarded as exothermic reaction. Dissolution of any concentrated acid in water for dilution is also termed as an exothermic reaction. Okay, now let us come back to the topic where we will be discussing about the formulas. Now, internal energy does not have a definite formula. Internal energy is only represented with U, but the enthalpy of the reaction has a formula. Enthalpy is del H of the reaction. Okay, this enthalpy del H is actually known as the change in enthalpy. Sorry, del means change, and enthalpy is equals to change in internal energy plus P delta V. What does P delta V stands for? P delta V actually stands for the work. Okay, pressure volume work done. Okay, pressure volume work done. So the change in internal energy, so the change in internal energy associated with the work done for a system, the change in internal energy which is associated with the work done of the system is actually the heat content of the system. Okay, so this is what heat content of the system actually designates. Now, from the ideal gas law, we can say that PV equals to nRT. Now we are doing P del V. Okay, where P is constant. Now can you tell me between N, R and T, among N, R and T, which one can be considered as a variable and which one can be considered as a constant?
Temperature is variable.
Temperature can be variable and also number of moles can be variable. Okay, number of moles
Hmm.
can also change, temperature can also change. So here P del V, we can write nR delta T or P del V equals to del N R T. Now, if pressure is kept constant, then according to Amentons law, we know that pressure is directly proportional to temperature. Okay, we can say pressure is directly proportional to temperature. But according to Charles' law, if pressure is constant for a system, then volume and temperature are directly proportional to each other. Amentons law has a form that volume should be constant. Okay, volume should be constant. But here as volume is variable, so we will say that temperature and pressure is constant, so we will say that it will follow Charles law. So temperature change can also occur. Okay, temperature change can also occur because of that reason. And the next part, if temperature is also not changing, then which one will change? The concentration or the number of moles of the reactants to the product side. If means the total number of moles of reactant and the total number of moles of the product, the stoichiometry, the amount. Okay, so let me explain it through a reaction. Suppose I have um, uh, 2 SO2 plus O2 to give 2 SO3. Okay, so here del N means 2 minus this 2 and this nothing means here it is 1. So 2 plus 1, 3. Okay, so this is 2 plus 1, 3. Okay, so all over my delta N is equals to minus 1. So all total delta N will be equals to minus 1 for this reaction. But if I have this type of reaction, H2 plus I2 to get twice of HI, H2 and I2 to get twice of HI, then delta N will be 2 minus 1 plus 1 or 0. Okay, 2 minus 1 plus 1 or 0. Delta N will be equals to 0. Understood? So this is how delta N is actually affecting the system. Okay, or affecting this.
Sir,
Tell me.
বলছিলাম যে মানে কেমিক্যাল ইকুয়েশনে মানে ধরো কোনো রিয়াকশন হলো তারপরে হচ্ছে নাম্বার অফ মোলস চেঞ্জ হলো না, তার মানে কি টেম্পারেচার চেঞ্জ হয়েছে? মানে
হ্যাঁ,
আইদার তো ডেল টি চেঞ্জ হবে বা ডেল এন চেঞ্জ হবে।
এক্স্যাক্টলি আইদার ডেল টি চেঞ্জ হবে অথবা ডেল এন চেঞ্জ হবে, বিকজ ওয়ার্কটা টোটালি জিরো কখন হবে? যদি টেম্পারেচার ইজ কেপ্ট কনস্ট্যান্ট, যেটা আমি বলছিলাম আইসোথার্মাল প্রসেসে যখন টেম্পারেচার ইজ কেপ্ট কনস্ট্যান্ট, ওকে, তখন ডেল টিটা তো অলরেডি জিরো হয়ে গেল, ডেলটিটা তো জিরো হয়েই গেল। এবার চেঞ্জ ইন টেম্পারেচারটা যদি কনস্ট্যান্ট হয়ে যায়, মানে ডেলটিটা যদি জিরো হয়ে যায়, দেন আমরা কি দেখতে পারবো যে আমার ভেতরকার যে এনার্জিটা, সেই এনার্জিটা অ্যাকচুয়ালি কোনো রকম ভাবে এফেক্ট করতে পারছে না সিস্টেমটা। For my internal energy to affect anything, the temperature of the system should change. If the temperature of a system is not changing, then my internal energy will not be used up. It will remain constant. And that is why আমরা isothermal যখন conditions পড়বো, isothermal মানে process for a reaction, যদি isothermal process দিয়ে যায়, তাহলে আমরা বলবো তার internal energy, change in internal energy is always zero. ওকে, এইখানে যখন আমরা ডিল করছি ফর আন্ডারস্ট্যান্ডিং ডেল এইচ ইজ অলওয়েজ হিট কন্টেন্ট অফ দ্য সিস্টেম। নাও ইফ দ্য চেঞ্জ ইন নাম্বার অফ মোলস মিনস, এটা কি, এটা টোটাল নাম্বার অফ মোলস যখন আমি কথা বলছি, চেঞ্জ ইন টোটাল নাম্বার অফ মোলস আর টোটাল চেঞ্জ ইন টেম্পারেচার যখন আমরা বলছি, টোটাল চেঞ্জ ইন টেম্পারেচার যখন ডেল এইচ আমি করছি, তখন সেইটাকে আমার ধরতেই হবে যে টোটাল চেঞ্জ ইন টেম্পারেচার হচ্ছে না কিছু, টেম্পারেচার ইজ ফিক্সড, মানে টেম্পারেচারটা আমি অ্যাজ এ কনস্ট্যান্ট পার্ট ধরে রাখছি। বুঝা গেল? তো আমাদের এইখানে একটা ইন্টিগ্রেশনের ফর্মুলা অনেক সময় আমাদেরকে লাগাতে হয়। উই সামটাইমস হ্যাভ টু অ্যাপ্লাই আ ফর্মুলা অফ ইন্টিগ্রেশন। সো হোয়াট ইজ দ্যাট ফর্মুলা? ফর্মুলা অফ ইন্টিগ্রেশন, সরি, ফর্মুলা অফ ডিফারেন্সিয়েশন হচ্ছে, সাপোজ আই হ্যাভ ডিডি এক্স অফ টু ভেরিয়েবলস, suppose I have TDX of two variables A and B. Okay, তো আমি বলবো একবার A DDX of B আর একবার B DDX of A. Okay, so this is the differentiation যেটা আমরা করতে পারি, differentiation with respect to X, যদি আমার এটা থাকে where A and B both are variables. So in this case যদি আমি এটাকে এক্সটেন্ড করি, NRT, যদি এখানে আমি টোটাল ডেল্টাটা দিই, তাহলে একবার আসবে RT ডেল্টা এন। ওকে, সো RT ডেল্টা এন একবার আসবে, প্লাস NR ডেল্টা টি আসবে, RT ডেল্টা এন আসবে আর NR ডেল্টা টি আসবে। এবার ইফ টেম্পারেচার ইজ কনস্ট্যান্ট, বিকজ আমি এনথ্যালপি অফ এ রিয়াকশনের কথা বলছি, তাহলে এই টেম্পারেচারটাকে আমাকে একটা কনস্ট্যান্ট টেম্পারেচার ধরতে হবে, দেন আই উইল গেট এই ডেল এন আর টি প্লাস এন আর টাইমস জিরো, টোটাল হয়ে গেল ডেল।
স্যার তুমি বললে এনথ্যালপিকে ধরছি তাই আহ, মানে ডেলটি জিরো কেন হবে, মানে বুঝলাম না মানে
ম্যাক্স,
জায়গাটা।
না, যখন আমি এনথ্যালপি মানে কি, হিট কন্টেন্ট অফ এ সিস্টেম ওর হিট কন্টেন্ট অফ এ রিয়াকশন, যখন আমি হিট কন্টেন্ট অফ এ রিয়াকশনের কথা বলছি, তো সেই হিট কন্টেন্টটা তো একটা ফিক্সড হিট, তাই না? ফিক্সড হিট। এবার এই ফিক্সড হিটের মধ্যে টেম্পারেচারটা কি হচ্ছে, একটা কনস্ট্যান্ট জায়গাতেই যাচ্ছে, মানে ওই সিস্টেম ওই রিয়াকশনের জন্য আমি টেম্পারেচারটা একটা ফিক্সড টেম্পারেচারেই যেতে পারছি। এবার সেইটার জন্য, ওইটার জন্য ওর একটা হিট কন্টেন্টের জন্য ওই টেম্পারেচারটাই দেখাবে, তার জন্য টেম্পারেচারটাকে আমরা মানে অ্যাজ এ কনস্ট্যান্ট টার্ম ধরে নিচ্ছি, whereas নাম্বার অফ মোলসটা সেখানে চেঞ্জ হচ্ছে। এবার যদি আমার নাম্বার অফ মোলসটা চেঞ্জ না হয়, নাম্বার অফ মোলসটা যদি কনস্ট্যান্ট থাকে, তখন অনেক সময় আমরা এই চেঞ্জ ইন টেম্পারেচারটাকে ধরতে পারি। ঠিক আছে, মানে এই যে এই রিয়াকশনটা আমি কেন দেখালাম, যে এইখানে নাম্বার অফ মোলসটা চেঞ্জ ইজ জিরো, দের ইজ নো চেঞ্জ ইন নাম্বার অফ মোলস, তাহলে কি তার এনথালপিটা জিরো হয়ে যাবে? মানে যে কোনো আইসোমোলার ইকুয়েশনে যদি আমরা বলি, যেখানে নাম্বার অফ মোলস অফ দি রিয়াক্ট্যান্ট ইজ ইকুয়ালস টু টোটাল নাম্বার অফ মোলস অফ দি প্রোডাক্ট, যদি এরকম যদি টাইপ অফ রিয়াকশন হয়, আইসোমোলার রিয়াকশন যদি হয়, তাহলে তার কি কোনো এনথালপি চেঞ্জ থাকবে না? তার থাকবে। তখন আমরা বলবো ডেল এন আর ডেল্টা টি। এবার সেখানে নাম্বার অফ মোলসটাকে আমরা কি ধরবো, হাউ, হোয়াট শুড আই টেক নাম্বার অফ মোলস? তো এইরকম এই জিনিসগুলোকে আমাদের ডিসকাস করতে হবে, মানে আমরা যখন আস্তে আস্তে কোয়েশ্চেনের প্যাটার্নে, যেমন আগে কনসেপ্টটাকে নিতে হবে। হোয়াট ইজ দ্য ফর্মুলা গিভেন? ডেল এইচ ইজ এনথ্যালপি অফ আ সিস্টেম or heat content of a system is the internal energy change, মানে আমি কতটা ইন্টারনাল এনার্জি ইউজ করছি to perform the work, how much internal energy change I am using to perform that work, সেই ওয়ার্কটা কি, সেই ওয়ার্কটার উপর ডিপেন্ড করছে যে আমার কি ধরনের জিনিসটা আছে। সাপোজ ওয়ার্কটা হচ্ছে আইসোবারিক, সাপোজ ওয়ার্কটা হচ্ছে আইসোবারিক কন্ডিশনে করছি, সো হোয়াট ইজ আইসোবারিক? প্রেশার ইজ কনস্ট্যান্ট। বাট যদি আইসোকোরিক হয়, তাহলে ভলিউম ইজ কনস্ট্যান্ট, তখন ডেল ভিটা জিরো হয়ে গেল। এবার ডেল ভিটা যেহেতু জিরো হয়ে গেল, তখন আমি কি বলবো যে তাহলে ডেল পি আমি ধরে নিই, ডেল পিটা আমি ধরে নিই, সেটা তো আমি বলতে পারছি না, কারণ ডেল এইচ যখন হিট কন্টেন্ট বলছি, তখন প্রেশারটাকে আমাকে, ফর অল দ্য সিস্টেম দ্য প্রেশার শুড বি কেপ্ট কনস্ট্যান্ট, একটা এক্সটার্নাল প্রেশারের এগেনস্টে আমরা কাজটা করছি। বোঝা গেল? হিট কন্টেন্ট অফ দ্য সিস্টেম।
তোর প্রেশারের জায়গাটা কি বললে আরেকবার বলো।
প্রেশারটা হচ্ছে আমি যখনই কোনো একটা রিয়াকশন করছি, whenever we are performing a reaction, the pressure should be kept constant। মানে আমি একটা পার্টিকুলার প্রেশারে রিয়াকশনটা করছি, আমি প্রেশারটাকে চেঞ্জ করছি না ডিউরিং দ্য কোর্স অফ দ্য রিয়াকশন। আর যদি আমাকে প্রেশার অ্যাপ্লাই করতে হয় তাহলে আমি একটা পার্টিকুলার প্রেশার অ্যাপ্লাই করে, যেরকম হিভার্স প্রসেস আমরা পড়ি বা অন্যান্য টাইপের কন্ট্যাক্ট প্রসেস আমরা পড়ি, সেইখানে কিন্তু একটা পার্টিকুলার টাইপের প্রেশারটাই কিন্তু করে রাখা আসছে। So we are applying a pressure, particular amount of pressure on the system, on the reaction system। সেই জায়গাটা আমাদের খুব ভালো করে বুঝে রাখতে হবে। বুঝা গেল? প্রেশারটা কিন্তু কনস্ট্যান্ট
হ্যাঁ স্যার।
হবে ফর এনি রিয়াকশন। সেটা আমি নর্মাল রিয়াকশনও করতে পারি বা অন্য ধরনের রিয়াকশনও করতে পারি। ইট শুড বি কেপ্ট কনস্ট্যান্ট। Understood? So this is the internal energy and the heat content of the system। Okay, internal energy and heat content of the system। So constant volume যদি আমার কাছে নিই, আইসোকোরিক প্রসেস যেটা আমি বললাম, সেখানে ডেল্টা এইচ অ্যান্ড ডেল্টা ই উইল বি সেম। আইসোকোরিক প্রসেসে, ফর আইসোকোরিক প্রসেস, ফর আইসোকোরিক প্রসেস, delta V is equals to 0 because isochoric means change, there will be no change in volume, so delta V will be 0. So therefore del H will be equals to del E. Okay, internal energy change and enthalpy change are almost same but with a very little point of difference. So delta E, or change in internal energy, we can write it as delta U as well. Okay, delta U. So it is nothing but it is the heat change at a constant. It can be stated as heat change at a constant temperature and volume. Okay, and delta H, heat change at a constant temperature and pressure. And now let me give an example to understand this fact. Suppose we are doing an reaction where we will see that there will be evolution of a gas, like we are heating calcium carbonate. We are taking an example that we are heating calcium carbonate, calcination of calcium carbonate, and you will get CaO and CO2. So here CO2 is the gas which will be produced, and as the gas produced, it will expand. Okay, it will expand in volume. Suppose I have added a piston over this reaction medium. So now as the gases are formed, so it will try to expand, it will try to push that piston up. We have, let us assume this reaction. This is calcium carbonate. We are heating it, okay, with a burner. Suppose it is put over a stand like this, and we have put a piston over on the top of it. Okay, now CO2 gas that is produced will push this piston up. Okay, this piston has no extra pressure, only the atmospheric pressure. Okay, the piston has only the atmospheric pressure above it and nothing else. Just piston is put and atmospheric pressure is acting over it. So now if this pistons move to this distance, that means the expansion has occurred in this region, in this reaction chamber. We can see that there is a expansion of work. We can see that there is a expansion of work because of the formation of CO2. Because of this, we will say that this system is working, or the system is expanding against the constant external pressure. The system is expanding against the constant external pressure. This is the thing which will be understood by this reaction, that the system is expanding, means the system is doing work, okay, against the surrounding, against the external pressure. Okay, this actually leads to two of the cases. That this leads to this actually leads to the case of expansion. So if the reaction proceeds with increasing volume, system has to expand against the atmospheric pressure in this case. In some other case, the external pressure can be the atmospheric pressure or cannot be the atmospheric pressure. So as it is expanding against the atmospheric pressure, an energy is required for this purpose. This energy is internal energy X plus some other energy should be there. The heat evolved in this case, okay, it is very little it can be because constant vol because it is less than the heat evolved during the constant volume thing, means internal energy change in that case, because we are heating the system as well. Here we are heating the system as well, so the change in internal energy with the heat evolved for that will be, and the heat evolved for this will be a very little difference between them. On the contrary, if we see that it is decreasing, that means this, instead of going up, it is decreasing, it's falling down, then what we will say? That the system is contracting, or the surrounding is compressing the system. So here compression work is done by the surrounding on the system. So either the volume will expand or the volume is decreasing. Here pressure is kept constant and the heating mode is also constant. So the temperature will also be constant. Okay, means it will rise to a specific amount and then it will not rise above it, because we know that every heating substance has a specific point, okay, as a limiting point of temperature rising. Temperature cannot even keeps on goes on rising and rising and rising and rising. Okay, it does not occur like that. It will rise to a certain extent and then it will stop. So the constant heating will increase the temperature to a specific height, and then the temperature, then it will be constant. So the two things, temperature is getting constant and volume is changed. So here P del V is actually written as del N RT, where this del N is change in the number of moles, change in the number of moles of gaseous, change in the number of moles of gaseous entities, okay, in the reaction. Okay, change in the number of moles of the gaseous entities in the reaction. If gases are being formed in the product side, expansion work will be done, and if less gases are formed, then compression work will happen in this reaction. So here, is it clear why the temperature change is not considered in this case? I'm not saying that it will never be considered, because in some cases we will come with the, when we will do the questions, I will tell you in those questions that where delta T will also come.